So we're going to talk about what scientific notation is and what we use it for in math and science. So in the world, there are some things that are really big, like the Earth or any other planet in space, and there's some things that are really small, like atoms and cells and grains of sand and stuff like that. And the difference between how we measure them is, in really, really small units of measure and really, really big units of measure. On this page, they kind of look like they're the same size, but we know that they're not. It's just the pictures that are there. So in real life, the Earth is like huge, 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 huge diameter, which is the measure across the Earth, right? So this here would be the diameter of the Earth. And if this proton or atom was round, let's pretend it's round, this diameter here would be really, really small. So trying to talk about the difference between those two sizes would be crazy, okay? So that's what scientific notation is used for, because if we had to put all the zeros to talk about how small this is and how huge this was, that would be a heck of a lot of zeros. So really quickly, let's just look at a really big number. So let's pick something, like the number of, people that are in the world, right? So let's find out what that is. I'm going to go Google it. So Wikipedia says that the population of the Earth is 7,442,000,000, and there's probably other numbers there, but that's all they give you, is 7,442,000,000. So that's a pretty big number. And see all these zeros here? That's stuff you don't have to write if you use scientific notation, which is kind of cool, right? Let's look at an example of a small number. So an example of a small number is kind of the width of a human hair, right? That is 0.00254 centimeters. So let's just do a quick review of the units here. So this is tenths, this is hundredths, this is thousandths, 10,000ths, and 100,000ths. So if you were going to look at this number as a fraction, it would be 254 100,000ths. So again, annoying zeros everywhere, right? So this is what scientific notation is used for. Okay, so now we're going to look at an example of how we would use scientific notation. All right, say you want to put the diameter of the Earth, which is 41,801,000 feet, in what we're going to call scientific notation. The general consensus among science and math people is that you have one digit before the decimal place and then as many as you're given. So you're going to write this as 4.1801, and then you have to figure out the power of 10 that you need to make these equal, right? So how many decimal places did we have originally to move it over, right? 1, 2, 3, 4, 5, 6, 7. So it's times 10 to the 7th. Now, why did we move it to the left? And why is this number a positive exponent? Because this is a really big number, right? So that makes sense that it's going to be 10 to the 7th. That's a huge number. 10 to the 7th, I think, is 10 million, which makes sense because this is supposed to be 41 million. You want this to be 10 millions in order for them to be equal. Okay, now let's do an example of a smaller one, and we'll talk about why they're different. Okay, so here we have a really, really, really small value. I don't even know if I can say it, right? So this is tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths. So that's 100 million centimeter. 1 millionth centimeter. That's so small. I mean, that's like crazy, right? It's so small that in the metric system, they actually made it I think it's a nanometer or a micrometer. I can't remember, and I'll have to go check. Anyway, so how do we write this in scientific notation? If you think about, let me get rid of all these lines so we can look at the decimal places there. I'll leave the fraction up. All right, so what's the number that's in here? It's just a 1. It's going to be times 10 to the something, some power that's up there, right? So we have to figure out what the power of 10 was multiplied by 1 to get this number. Now, because this is so small, is it going to be a positive number or a negative number? The one we just did with the Earth was positive because it's so huge. If it's really small, it's going to be a negative number, right? So we have to look for a negative value that is going to express this exponent, okay? So let's think about that. When we look at the decimal places, this is 1/10, so that's -1. This would be -2, -3, -4, -5, -6, -7, -8. So it's 10 to the -8. So you're looking at where that decimal place, 1.0 times 10 to the -8, is the same as this. But you're writing it without all those zeros there. So one of the things you're doing is you have to remember, it's like, how many times did you move that decimal place over, right? So this was 8 times. -1, -2, -3, -4, -5, -6, -7, -8. Okay, sounds good. Okay, so I just want to make a distinction between how you're doing this in a positive way and a negative way. So for a number like 300, right, you're going to do 3.0 times 10, and you're going to go 1, 2, 10 squared, so that's hundredths, right? Here, this is going to be 3.0 times 10, and go back here, 1, 2, right, to the -2. Does that make sense? So if you think about it, where was the decimal place originally? Here, when you don't see it, because it's just a positive number. Here, where you do see it, because it's a decimal. So that's just a really important difference, that you actually see it and you say -1, -2. Here, you're actually going 1, 2. So this is 100. This number here that you have is 100. Here, this number you have here is 100th. Okay, I hope that helps.